Okay, you're on.
Ladies and gentlemen, without further ado, Kevin McCarron.
Come on!
Woo! Woo! Yay! Love you!
For those of you who don't know, I'm Kevin McCarron, and once again, I am trying to teach for 30 years without an original idea. So,
3, 4.
steal everything from you guys. And along those lines, I just want to show you a few projects that we've started here.
And stolen.
Remember that the WISE project was looking for the asteroids and looking for the light curves, and we had the Astro Spud that would spin around. Kevin, being incredibly lazy and cheap, decided he wanted to have someone else spin the spud for him, but no one else would do that. However, he did get this. Here we have the Astro Spud spinner. You can see it spinning there.
Oh yeah, it's screaming.
Yeah, it's spinning.
Whoa, it's almost as good as mine.
Yeah, it's going at 2/3 RPM, but it's turning. We can put the spud on here, and students can take the measurements. We even had when we built these using a $2 motor and a $2 AC to AC converter, and probably about $2 worth of wood. But we had to have the really expensive part, the $3.99 voltmeter, hooked up to we did hook it up originally to a photoresistor, but I found out that LEDs work backwards. So if you shine light on them, they'll actually create a voltage. And then that way, if you have more light, you have more voltage, so your numbers will go up. And I found that LEDs are cheaper than photoresistors. So, being the cheapskate that I am, now we have these hooked up to LEDs, and I don't know how sensitive they are to different, like if you have yellow light shining on a green LED, I don't know. I haven't tried that part yet. Somebody needs to do that. But this is our sensor, so we hold it here, and the students have the light shining on the spud and take the readings every 10 seconds and graph it. Of course, they don't know how to graph, so we go back through the graphing again every time that happens. But the Astro Spud spinner. Also, being the cheapskate, eyepieces. We did this a few years ago, but I do have more lenses. We can make your own eyepieces using, of course, Kevin's favorite building material, a PVC and
glue.
Well, glue maybe, but the big thing is the Dremel tool.
Oh,
Gotta have a
Dremel
tool. That's the best part. So we can make cheap eyepieces. I think this one, with everything, it was somewhere around $8, maybe $5, but I can't remember. Today, though, what we're going to do is we're going to make our own spectra. So here I have two different versions of this. We do have stuff to make both of them, although I have limited numbers for this. But this is going to be really lame because in a really bright lit room, here's the spectra.
Oh yeah, look at that. It's
actually you can show. That works really good, yeah.
But this is if they are in series with a 9-volt battery.
Have to roll reverse row. Yeah, see. Yeah.
But if you put them in parallel, if you put them in parallel with 3.5 volts, they're a lot brighter, but they also, I don't have enough materials for everybody to do that one. So, yeah. So you have to change. You have to decide which one you're going to do because they're wired differently. The
one's in series.
3.5 volt has to be in parallel, and you got to figure out how to do that. The 9 volt is much easier to do. So that's our project for today. So you should have a foam board. You should have a switch.
On and off, on and off.
The ON-OFF discriminator, as we call it in the business. You should have yeah. You should have a battery, 9-volt battery.
You want to test it? And it has to be live, yes.
Please do not test anybody else's battery. And you should have a battery connector. And you should have a red LED. Okay, note on the LED there's two sides to it. Yes, the dark side loop, no. There's only the light side. But notice that there's one prong that is longer than the other. That's important. The longer prong is the one that gets hooked up to the, was it quiz? I don't remember. Positive. And if you look at the other side, the shorter side has a flat side on it, on the plastic. So
That's negative.
So there's two prongs here.
I did.
This side gets hooked up to positive.
You do that very well, by the way.
Cameron.
And the other side here, one side is sort of cut off like this in the plastic. That side hooked up. So the first thing you have to do is prepare your foam board. So for your foam board, you need to put in 6 receptacles. You have 6 receptacle producers on your table. Oh, sorry. You need to put the holes in. So there should be either a drill bit or a screwdriver that is approximately the right size that you're going to put in your sticks. You want to put them fairly close together, maybe a centimeter apart. Can you use a pen? Yes. Because the problem is when I give you the orange one, you won't know the orange one from the red. So you want to, I'm only going to give you one, then I'm going to give you the orange. Right. Exactly. Spacing's the same, yeah. Actually, I would put it a little bit closer together, maybe half a centimeter apart. If you want to do the 3-bolt.
Say that once again.
If you want to do the 3-bolt, I would put them closer together, maybe half a centimeter apart.
Wear safety glasses.
These are a centimeter, these are about a half.
It's more like
maybe 2 centimeters.
for safety.
Maybe 2 centimeters then. Fine.
You got the wrong system.
Actually, I'm not going to tell your mom. I am now.
If you want.
So we're doing 6?
You're going to do 6.
The casting on this was really important.
How far apart?
About a centimeter to 2 centimeters apart for the holes.
Red. And
At the bottom of these, once you have all those 6 in there, what you're going to do is you're going to put a larger hole for your switch. Different switches are different sizes, so you may have to put a larger or a smaller hole. You can use scissors to try and cut that hole more square. Doesn't really matter. But you want to try and keep the...
5.
You want to borrow this? Yeah, I'm just going to eat.
You can do 5 or 6.
Now, Kevin,
Yes.
you see how Tom always does it a different way.
Yes.
Is there anything wrong with that way?
Is there anything wrong with that way? No. I recommend putting it in from behind will make it a little bit easier to manage.
When you start,
But once it
Well,
doesn't
see, yeah.
make a whole lot of difference.
yeah.
But I like mine flush mounted, you see.
Okay.
I could go the other way.
Well, the other thing is you can punch holes with that way. You can punch 2 holes with a push pin.
That's nice.
We're going to be doing this as well.
Yes. Either or.
This is the harder one.
And we
I'll
all
go
know
back to my
how
old
much
one.
kids like to have push pins.
Right.
What he did with his, went up this way with it. So this part is under. I went to the top because I don't pay much attention to anything.
Switch signal.
Actually, I would. We do have push pins.
You have sockets for attaching the wires together. One is to solder them. We do have soldering irons, and the other is to crimp them together.
Oh, so you can
That'll be
put
big
each
enough.
pin through,
Each
yeah.
pin through a hole. They'll be insulated from one another.
I will try that. That's not a bad
See if
idea.
it works.
I'm gonna do it over here. This is a testing
As
area.
long as you're doing it different, we can test out
Different theories.
different ways.
I fully agree.
This is, you know, in the new standards, engineering, in the new science standards, engineering is
Getting up there.
If you wish to print them, what I recommend are these print tools. I don't have a lot of things to print with.
What I've done is make little holes.
You want print
So you take this, you put one in one hole, one lead, and the second lead in the other one, and you can break it. No.
does it actually fit? I mean,
That's what I'm trying to find out right now. I think, yeah.
huh. Well, all right then.
This way here, leads are separated and insulated, so you won't get a short. Both will work. And Kevin's. We can print it.
Yeah, it works good. It works good, and it's not that hard to make the hole. I don't know why I'm doing this. I don't have an LED. There's a board in front of me.
That's right. We're letting you practice.
Yeah. If it's good enough, they'll give me an LED.
That's it.
A bigger hole in the bottom.
Right.
So we need a
Okay, once you have the holes in there, you have your red LED in.
Yep.
I put it in the other side. Okay.
There's six LEDs?
Red LED going on.
5 or 6, yeah.
The original one.
Okay. No. Kevin always has the best, the most neat to make it.
Switch it now.
The first LED?
That's the first LED.
Okay.
I recommend going so that they
Roy G. Viv.
go up from the bottom so they just barely stick out, but either way works just fine. It's just a little bit easier to keep track of long and short, I found, if I push them up from the bottom, because then you can see the flatter side easier, but it doesn't make a whole lot of difference.
Any recommendation of red on top or red on the bottom?
Yes.
Do you think we'll use it? Does he recommend putting it on the top and bottom, not the middle?
All right. This is very key now.
You want this?
You want to attach your switch to the red wire on your battery. I wouldn't connect your battery. I wouldn't put the battery on there yet, but connect it to the battery connector. So one wire of the switch goes to the battery connector.
Either one?
Either one. It doesn't matter. The switch is not full.
I'm stripping, this is the switch, this is the battery holder, and I'm connecting the positive lead
You want to
to any
solder.
of the leads of the switch.
I recommend probably be best
I'm twisting the wires together.
soldering irons that are battery operated.
You can use a soldering iron, you have to watch how I can. The other thing they could use, you can use screw caps, and that'll lock in, or you can use tape. And when you tape it over, tape it, fold it over, and then you tape it again. It keeps the wire secure. It's very cheap.
Only got a couple.
Insulating tape, yes. Electrical tape, correct.
I would recommend the red LED close to the switch, but it doesn't matter. You've already got the red one there. I would, if you put it there, that would make it a little bit easier, but it doesn't matter which way it's easy.
Meanwhile, Alan's putting his switch together.
What?
No, it's just
Well,
Get it?
Can I borrow your pen?
Once again,
Absolutely, sir. Be my guest.
red wire to the other end of the switch to the long end.
Are you enjoying yourself?
Well,
What? You can put it. You don't have to show it on me.
That's so people can learn how to do.
Well, one way to learn how to do it is to see the cameraman. Have to watch everything. Okay, this is the surface mounted switch concept.
I'm not sure how you do it.
Yeah, well, I used Tom's pen and made two big holes in both sides, stuck the wire through, and just pressed it down. So it's just not really all that secure, but it would be if I just actually, this would be pretty good. I'll just twist the wires around, and then it won't come off. They're fully insulated.
Anyway, thank you, sir.
Of course, I did do it the wrong way, but I'll just move the LED down closer to the switch.
I forgot to mount the switch.
Okay, so where's the switch?
You're from Portugal?
okay, I'm going to pass out an orange LED to everybody.
Thank you, sir.
Solder is over on the table over there.
Now, I was always taught in soldering that you always make a very good mechanical connection first. So that means you crimp two wires together first. So it really, mechanical connection is holding them together. And then the solder just...
So the connection flows?
Yeah.
The electric...
Yeah, the solder just makes it
How
good.
did you do?
Well, I just bent one wire over and bent the other wire over it and attached them together. So that makes a good mechanical connection, which actually would probably work without solder. I think that might work without solder.
So, yeah, if you don't...
Oh,
I'm pretty sure it would work without solder.
yeah. But actually, what does it matter which lead you hook it to? Or was I supposed to put it on the battery? He didn't say anything about battery. What? He said connected to the battery? Oh.
Well, just one lead. What's that again?
Short end of the orange goes, long end of orange goes to short end of red.
Got it. What he's talking about there is that when you go in series, you have to have the diodes flowing in the same direction. So, whoops. Very graceful when I drop things. This short end is the negative. The long end is the positive. So if I'm going to connect this in series, let's say I connect this to the switch, this one here, which is the positive lead, I would have to connect to, can I borrow your orange one for a second? I'll
My
give right
what?
back. Your orange LED.
Did he give me one?
You're supposed, right there.
Oh,
Right there, okay.
oh, just
So if you're going to do it in series, what you do is, remember, this is the long one. This is the positive. I'm going to take the positive and I'm going to connect it to the short end of the next LED. That's negative. So you go positive, negative, positive, negative. So you tie these together, and this one here would follow in the same line. It would connect to the negative of the other.
You can try that.
Make sense? Well, if we verified, I make sense. That's unusual. Ask my wife. Anyway, so there. Okay.
You know what, if we disconnect the video for a second.
Can I do
No, I'll see what you're doing, but we could show the, his diagram.
connect here?
Yeah, and then just hold it in front of the diagram. And then come back. Actually, you can. That's the time.
Very proud. This is where all the LEDs are. I think don't actually cut that. So don't crush it.
We were just showing a diagram.
Okay.
You want this connected?
This is positive.
Actually, I can. Can you make sure you're on
I am on the screen. Thank you, Dave.
the whole world is watching, right?
Really?
Well, and it's
Yeah, if
recorded
you look
too.
very carefully, you'll notice that
It's for posterity.
posterity. Huh?
Yeah.
That's right.
So what I'm doing mechanically is I'm tying it up in series. Negative, this was a positive, negative, this is a positive, and connect to a negative, bring it around, bring it back. But I have to wait for Kevin to give us LEDs.
More LEDs. More LEDs. You got your orange?
Yes, I have my orange in.
Okay. But I don't have my battery.
Orange, you happy?
Yeah.
Orange, you happy? That's how I talk to 30 people. Don't give them much content, but make them laugh. Killer. New Hampshire. On the northeast. Turn me on, turn me off. Turn me on, turn me off. That's how easy it is. We were brothers in a previous life.
That's right.
Okay, how's it going, partners?
Pretty good.
Oh.
I'm gonna get 3 volts out of this. So
You're going with the big baby?
I don't know. Well, he didn't. Did he give me? Oh, he gave me that. Okay.
Sure, there you go.
I get it.
If you want that one, you can have it.
I do want it, but I need to attach it.
Anyways, what do you call a cow leg? Think about it. Yes. Ground beef.
Kevin. Kevin.
I need a yellow.
Yellow.
Kelly.
You gotta get go.
I'm gonna go.
Go get it.
If you want to have a couple.
You're in Harrisburg. This is the place to go. Brass, Huff, and say Tom sent you.
Make it feel out.
Oh no, my daughter was right.
Oh, okay. There's the yellow. Stop.
So the short end of the orange goes to the long end of the yellow.
Tom.
Okay, this is how we're doing it. So going into the launch.
There's the yellow.
This short point is long.
Peggy is distributing the yellow.
So Kevin, do you have some 1.5 volt ones?
There's one. Here's one. Did you want
No, I meant the actual battery.
the actual battery?
Yeah, no.
I'll give that to Alan. I'll give that to Alan. Yeah, because Alan needs it.
With the defective.
Oh, I know. Here's what we do. Here you go, Alan. Your yellow.
Thank you. I'll need to borrow your pen.
You can borrow my pen anyhow.
Okay. All right. There we go. So I need to review the negative. Either goes to positive.
Negative goes to positive.
Yeah. But the actual battery.
I think we'll have to click.
Okay, this is the negative. Okay, the negative end is
the black.
here. Is the black? And that goes to the negative side of the LED, the longer, or no, the shorter.
Shorter.
The shorter.
Negative.
So that means the positive one goes to the
We're an interesting culture, aren't we? For some reason.
Okay, this is again. Caught up.
LED. Portuguese. Yeah, and the food. Linguiça, the fresh bread, always very good.
I don't recommend connecting your battery yet. These are not made to take 9 volts. Oh. I'm passing out the green.
Green.
Rich, you're right.
What? I'm right? What?
You were correct.
About.
9 volts.
Oh yeah, 9 volts across an LED.
Blow it.
I think you didn't pop.
Smoke.
Do we need, can we get a different resistor for using in series? Same. Yeah. We still need
You know, if you probably have it pointing over in the other direction,
Oh yeah, I missed
playing busy, because I'm getting camera shy.
Could walk around, huh?
Yeah.
Go control.
Thank you.
We've got one more green LED. Anybody need that one? Green or more.
which is yellow after.
The wire.
Red. Let me go put the defect.
Green.
Right here, green.
Uh-oh. Oh, no.
Answer.
So whichever way you start it.
Bummers.
And green goes after that, right?
At green?
like green?
I have green, thanks.
Oh, I love a little tiny blue. Did you already have green top?
Yes, I do, thank you.
Anybody else need green up there?
Long end of blue goes to short.
Red, orange, yellow, green.
She wants mechanically to know how to print. Howdy, partners.
Howdy, partners. How you doing? I have confidence in yourself. Lou, thank you. Have violet.
If you want to try and get, I do have a violet, but it doesn't,
Violet very well.
well, you'd end up, light it, so then it's almost impossible to see.
You only have 5?
Fine,
Whoa.
Okay, where'd my other LED go? Oh, there it is.
No?
Yeah, I'm working on my last LED.
Let's try and find it strong.
Pardon? Yes. Well, what I've got now, I've got all the LEDs in, long wavelength to shortest, red, orange, yellow, green, and purple. I didn't put the violet in because it's too dim. I've got the switch, have the switch connected on one end, and I'm waiting to put, get instructions on when to put the battery in. Now, we're going to be using a 9-volt battery, and unfortunately, a 9-volt battery with LEDs in series, they'll blow. Too much current is going through. So we're probably going to have a resistor connected in series with it to drop down the current, so therefore they won't blow. That's what we are doing. And by the way, don't do this at home. Ah, yes, it works.
Did you lit them up?
Yeah, I lit my tongue up. I'm waiting for the...
you didn't.
I don't know. I think we need a resistor
didn't
to
give
go
it
with the
the-
knife.
No.
Yes. Are we going to need a
No,
resistor
there's
to
no resistor.
work this in series
you shouldn't,
with a 9-volt?
you should not.
Okay, then I won't. Where would you like me to put the battery? Or is that a proper terminology?
I would love to tell you where to put the battery, but I'd probably get fired.
Should I have it out here? I should have it out here.
You're on camera, you
On the
know.
back? On the back or?
On the back, I would recommend.
Okay, I will then, sir. Always listen.
This was the man on camera.
It's all...
The violet will work only if you use parallel.
That's positive, this has to go positive. Now connecting the ends, positive goes to positive with the ends.
Am I showing the right thing?
I think you are, yes. Right here. Red is positive, black is negative. And you want to make sure that you connect the positive with the positive and negative here is negative. And so the current will all be going in one direction. If I have it reversed, it may not work. Way to use it. Now, you can crimp if you like, but I'm lazy. I crimp later. First thing I do is you strip a little wire off.
If you have parallel, you can go ahead and press that.
You can use the scissors.
Use scissors.
And regular people do.
Regular people use scissors or
That is not a good pedagogical thing.
but you know, for the last 60 years, for the most part, it worked. So when I did electronics, the space between my teeth was a little bit closer. I used to strip wire all the time like that. I didn't have time. I've made my mechanical connections. I know that it looks a little, before I crimp anything, or before I solder anything, I like to dry wire it first. In this way here, I can kind of check to see if I got good mechanical connections. And then when I'm satisfied that I can then go along and solder everything right off very quickly.
Now, why does the grid sometimes
What do you
out?
What do you mean?
What is that for your battery?
Hold the battery down?
Yeah, you can get a battery.
But sometimes I get it brighter. Like, sometimes when they're not brighter. This is the layers of
Tested. If you see smoke, don't worry, you're far enough away that you won't get burned.
but my own voltage is sometimes, and then I can drop it to be brighter. No, I didn't even follow you.
Well, that mechanical connection didn't work, but my switch got it. I'm not going to go there. There might be trouble.
Thank you.
You're welcome.
Oh, that's a solution to it. Kevin, I guess you need that here.
You need what?
What you have in hand.
Oh,
It's only going to be happy.
Thank you.
you want.
That will never happen again.
It'll never happen again. All we've done is we've taken double-sided that we bought for $1.95 at the local hardware store.
Yeah, it's not my mom. But she likes it. Yeah. Well, yeah. One day
Now, I've checked to see if it works. Guess what? It does. Now what I'll do is I'll solder the paper. I'll make sure everything is laying down flat. And inspect it. Thank you.
You're going to go back here because the camera makes the same size.
All right?
Yeah, that's good.
We can do a light show. La, da, 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 da. Oh, music. We need music.
Yeah, music. How are we doing for time anyway?
Well, let's see. It says it's 4:52 right now. But that's my clock time. I don't know. I don't have my. I think it's an hour early. Are we over? Sometimes we sacrifice.
It's 3:50.
Yeah, I'm off by an hour.
Which means how are we doing schedule-wise?
Okay. So he's going to
Actually, I need to connect up with Chander. Chander, the next speaker.
Oh, okay.
Need to do a status check.
I'll type an email right now. Okay.
Wait a minute. No, that's not right. Maybe it's not. 3:52.
Central time.
Yeah, 4 o'clock he's on. He should be coming in to our site. Get Chander online. Oh, there he is. Chander.
Hello.
Is that Chander?
Hi, Alan. I can't hear you. It's coming very.
Can you hear me?
Yeah, now it's okay.
I can hear you okay. Let's see.
Yeah.
Can you? There's a lot of noise in the here.
Yeah. In background, there's a lot of noise.
Yeah, there's a work. We're finishing up the workshop session, so there's a lot of background noise. But I can hear you fine. Let me give you presenter status, okay? Chander?
There you go.
Chander, I'll give you presenter status. Okay?
Yeah.
Co-presenter.
Yeah, it's logging into the server now.
Okay. Chander has presenter status. Okay, we're ready.
I have it.
Good. Let me just check where we're at. Hold on. Okay, I think we're pretty much on schedule. We'll switch over control to Chander in about 5 minutes.
Okay.
We're going to wrap up and move on. We have things that haven't been finished yet. We are going to work on this after the end of the presentation this afternoon. We'll finish these up.
Yeah. Let me
The
switch
next
out.
person will have a PowerPoint?
Yes. Okay.
So stop sharing.
Okay.
Bye-bye.
Yeah. Okay, Chander, you can turn on your desktop sharing.
Thank you. Please stand by.